So welcome everyone. This is session on the agentic AI, and welcome all of you. I hope that you have been already going through multiple AI solutioning and enterprise AI solutions, and you have faced multiple challenges in terms of agentic AI deployment. And we have seen a lot of issues right now in terms of AI guardrails, the MCPs, and the compliance. So compliance stops us from implementing it and deploying it. So we have been building the enterprise AI solutions for a long time, but for one or some reasons we could not deploy it because there are multiple risks here. So today we talk about those risks and how to mitigate those risks. So I will share my screen and and we can just start from the first slide. Let me share my screen right now. I just say hi to everyone first of all. One second, PPT. So first, hi from my side. This is Naveen. I'll just this topic is the production ready agentic AI, the MCP governance and evolution. So it's all about production ready agentic AI. It is not just like building something in MCP, building something for MVP and just leaving it. It's all about production ready agentic AI. And this is Naveen, who represent India at ITU Geneva for AI and generative AI. So topic is very interesting. So it's all about you're trying to get Gen AI blueprint in terms of deployment and the production. So I'll just start with the basic idea, how things evolve basically. The MCP, what MCP is right now. So generally we used to have earlier the APIs and all. So the what we have API earlier, now we have MCP. MCP is like a plug and play game. So example, you are having a fintech company and fintech solutioning, so you will try to approve the customers. You just try to fetch data from for customers. You just approve the loan. So there are multiple things which a agent can do. Mostly there we create the MCP tools which perform each task. So we dedicate MCP tools for various tasks. So every production agent costs 8 cents to 50 cents per task. And without governance, a single runaway agent can bond. So generally, when you deploy any agentic AI solution and all, you suppose you are trying to deploy something for any email solutioning or whatever calendar solutioning or approval of loan or whatever and all. So when there is a very nominal charge, but when there is a tragedy, when there is some incident, there's some kind of issue right now, in that issue, you find that suddenly there is a very high cost. Example, you are running, you are deploy some agentic AI right now. Maybe after 2 weeks or 3 weeks, you come across one event where you found out there is a big challenge. There is a big burnout suddenly. There is a big some challenges which penalize the company $10,000 and all. We have seen that running cost looks very simple, but without governance, without compliance, a single runaway agent can burn $10,000. Especially when you try to deploy in your industrial system, like manufacturing unit and all, in the plants, in these manufacturing units and all, then there is a bigger cost because you will damage all this turbine and all. So I'm talking about here right now, typical typical IT solutions. So the risk is very high, $10,000 and all. So company which we have audited spend 40% of their agent budget on redoing failed and redundant tool calls. So governance generally looks like a cost, but in reality it saved the money. So generally the perception in the market is that you are having extra cost for governance, but in reality the governance reduce the cost. There is a risk, there is a penalty, there is a lot of issue right now. So somehow governance try to reduce those challenges, and finally at the end of the day you save the money. One financial service example, you are handling the suppose loan service basically. So in loan service you can have multiple agents, three agents. You can use many MCP tools. They tools to access the database, tools to fetch the system, something for system. So you can have multiple MCP tools. So you found that without governance, you found if there no governance at all, so first production incident, the first incident, first accident in the your loan cases, they can it can go up to 47K, 50K, in one go. Example, you are approving the loan, and one agent approved the loan. Out of some scenario, there is a wrong person, and the agent somehow just overlook and just approve the loan. So this kind of incident, the burned a lot of money that time. So one financial service which has a multiple agents and multiple MCP tools, we found that eventually one incident in a month or whatever will cost 47K, 50K, in general. And OPA policy is like open policy, So OPA policy is governance layer plus approval workflow would have been. So if you apply the governance, you will have a much lower cost. So you will hardly pay 1/10 of the money. So governance really reduce the whole cost. This is the message of this slide, that unlike the notion in the market that governance and compliance increase the cost, in reality, it saves the money. It reduces the incidents and it saves the money. So OPA approval generally have been less than $2,000. So compare it 2K and 47K. So this is data from the market. So industry data is there right now. So 2K is the normal cost to run the show of this fintech service, and 47K just like a one incident penalty and all sort of. So that is the difference which we are bring through the governance. So we are talking about governance here. So let's talk about numbers. So like customer support, generally they have 10,000 average calls per day, and it if you don't have any kind of governance, so you expect $800 to $1,500 per day. So generally you charge around $1,000 per day, if there no governance. If you put a because if there is a wrong call, if the agent has a wrong kind of calculations and pass to the customer and all, generally we have seen that without governance, when you deploy the customer care agent solution, you tend to spend 1,000 $2,000 per day. But when you apply the governance layer, then your cost reduces drastically, around like 100, 200 kind of, range. So we expect quite different, 6 times, 7 times less charges. Same with the data analysis agent. Suppose you are having a data analysis agent basically, which works on your financial data or any insurance data or any data basically. So even you can see here, you reduce 40 $40 per day to the $6 per day sort of. So there is a data from the market, and we have seen the A/B testing right now. 800 becomes 120, like 7 times less. 40 becomes $6. Okay, and DevOps automations again 200 to 500, 500 to just $2 basically. So what the message is that you should try to leverage the compliance layer OPA policy, so that you will have a lower running cost with a better compliance. So you have two advantage: lower cost plus better compliance with the industry. Okay. So I'll show you the other scenario, like other aspect, like risk and compliance, CISO and the CTO focus. So traditional audit expect deterministic paths. Agents are probabilistic. Example, LLMs are probabilistic. LLM cannot have a same answer all the time. So our compliance framework must evolve from what happened to what did the agent choose what. For example, when you have a governance and compliance, generally they are futuristic. They are pro. They always they always try to have logic, inbuilt logic, which try to understand why we should do that way, not that way. So they have a logic inbuilt. Compliance generally has a logic inbuilt to prevent a lot of accidents. Okay, so there is a lot of logic difference between the logging and the compliance. Logging means post-mortem report. Example, whatever happened to the company, you see the log data and you find out the problem, root cause and all. But compliance is all about futuristic thing. You are doing the proactive job. You're trying to prevent a lot of accidents and the bad things in the company, sort of. So we have seen that three patterns of the agent failure. One is a tool misuse. Generally, tools are misused. MCP tools like emailing, fetching the databases, or putting into CRM and all. Those tools generally we give the more than privilege. Example, one tool must have access to these points, but if you give lot of access to the tool, So tools can reach out to other things and can really disturb the system. So we try to believe that we must give the least privilege system so that tools may not have the power to misuse and uh, run over databases or pull the very secret data from the database. Context poisoning. So example, if context is confused by the system, so they try to go into other domain and disturb the whole thing. They will really kill the system. So they will misunderstand thing and they will go and do something else in the other database. Example, one MCP tool is supposed to handle this database, but if the context is poisoned, confusing, what happens? This tool can go into different database and just pull the some data which is not public, which is bit private data. So we okay, and third is the goal misalignment. If the agent prompt is not correct, goal is not clearly well defined. So if there is a goal, so there are three main problem of the agent failure: tool misuse, tool works differently than what it intends to. Context is not so clear. Context is poisoned by some logic or by some complex environment or the goal misalignments. If we don't define the proper goal of the agent, so they may go differently in a very different scenarios. So each requires different governance. So we have to really take care of all those aspects. It's all about being futuristic and figure out what can go wrong if tool is misused and then what can be done to mitigate that. Same thing we do for the context poisoning. Governance can figure out what can go wrong when context poisoning happens and how to mitigate that. Same thing, there is governance rules we can find out when goal misalignment happens, find the when it happens and how to mitigate that. The governance handles all those possibility and also mitigate that. That's why we want to deploy the governance. So any question, please raise your hand also. Okay. So one example here you can see here, tool misuse like a wrong tool, wrong parameters and all. So we can see that we apply the least privilege system where tools will not get a chance to get different access altogether. So whatever you require for the tools, they will get only that much access. They will not get other access. OPO is like open policy thing. So example, we can have a decision logic basically. So when you this is the method to mitigate those challenges. So when the tool misuses and the governance identify that problem, the governance try to enforce this logic. Okay, so this logic tries to solve the problem of tool misuse. Now, same thing with the trajectory evolutions. So this is the strategy of governance. When you apply any governance like OPA policy in the agentic system, so you are somehow preventing and mitigating those challenges of tool misuse and context poisoning and the goal misalignment. Okay, so this is the strategy to mitigate those problem, those challenges, and it's a lot of money also, and also being the it will not damage the company reputation also. Okay, so third angle you can say technical depth. So MCP killer feature is not standardizations; it is dynamic tool. Yes, Pooja, please. Yes, Pooja, you raise your hand. Okay, okay. Any question, Pooja? Okay, then let me now continue then. So MCP killer feature is not standardizations; it's a dynamic tool discovery. I think you are mute. I think
Puja, for
can
now,
someone
you can only type your question in the chat. You will be your mic will be enabled towards the end, like I said in my messages. So if you have a question, you can type in for now,
yeah,
and we
thank
can
you.
read and answer that.
Yeah. Okay. You can type basically, I just answer it. So MCP killer feature is not standardization, it's a dynamic tool discovery. For example, MCP tool can go and fetch that one data from the database. Like customer apply for the loan, so they will fetch the transaction history of the customer. That is a one MCP tool. So it is dynamic tool discovery. Your agent does not need tool descriptions hard coded. So since you have LLM brain, it doesn't need to be hard coded. It asks the MCP server, what can you do at runtime? So what I want to say basically MCP tool since it's dynamic, since it's powered by some extra logic, so they are very dynamic. So there is chance of error, there chance of going into the other database also. So MCP is a live system, is a dynamic system. So we are supposed to keep one extra layer to prevent the bad things which can happen due to the MCP tools. Open policy agent gives you policy as a code for agents. Same Rigo policy and all. Rigo is a script code. Rigo is a script code. It means you write the policy or logic, decision logic in the Rigo logic, Rigo code. Rigo is the script language sort of. So you will write a logic that do this, do this, do this, and all. So you write some logical thing in this Rigo language. Okay, this is OPA. So same Rigo policy that govern your Kubernetes cluster can govern your agent also. So one control plane, two workloads. Now LLM as a judge has a 70-80% agreement with the humans depending on the task. So that's the production grade for the high stakes. So mostly LLM as a judge has 70-80% agreement with the humans to depend. So we expect LLM like GPT-4 or GPT-5 may not always do the great job. They may not be aligned with what you tend to, what you aim at. So sometimes you find that they have they misalignment. In that scenario, you have to be ready. You have to be ready to prevent the bad things or any incident. So that's where production issue comes. So many big leader in the company, they build the agent, but they build it, they build the MVP of the agent, but they don't deploy because of this only. If you deploy, there is chance that LLM can misbehave, LLM can hallucinate, can also understand it differently, and there can be a wrong judgment by LLM as per the business goal. So that's why people are not able to go for the production grade agentic system. Okay. So use agent as a judge for auditability. Two agents, one acts, one critic. So there is one strategy called agent as a judge. What happens? You create one extra layer. You create one extra layer, which layer try to judge what LLM is doing and all. So we try to create those system agent as a judge for auditability. Two agents, one acts, one critic. So basically, there will be one agent will do some task. Second agent will try to criticize that, and figure out what it can go wrong and all. So we create those kind of systems to counter the challenges. So I can explain you later on also like what AMA stands for. AMA is one strategy in the agentic world. Now trajectory evolution is a difference between did the agent succeed and would I trust this agent with my production data and all. So the format is a metric. So trajectory, I can if you remember in the last slide we have done right now already. So I'll show you right now. This is right now. In the context poisoning, basically issue, the governance say apply the use the trajectory evolution and all. So they'll try to analyze step one to step two to step three and all. They analyze that whether we are navigating in right way or not. Okay. Now governance artifacts you need. So you already know that in the policy decisions you have a Rigo code. We apply this Rigo code by the way, and this code will try to make the policy. Okay, trajectory score. So this is a typical format. So policy is done in the Rigo logic. Logic tool call logs. Log will happen in JSON format, right? Then trajectory traces, open inference, and then we have human approval. So this is a typical format in which we handle it. So when you try to deploy that, you will figure out. You can see this example right now. So Rigo, this is the code of Rigo. Rigo allow, no allow, allow false, region, role. So basically, this is the language of the Rigo. So when you import this strategy, policy decision, Rigo, you can see that this is you apply this kind of logic So when you deploy the agentic AI in production, you just take care of this aspect. Okay, tool call logs for traceability, policy decision, trajectory trace, and human approval. Okay, so these are the typical methods to manage the risk, mitigate the risk, which come in the LLM systems. Okay, so keep in mind these four artifacts which are required to manage the governance of LLM based systems. Now, let me share with you as a strategic leader, VP, if you are senior leader in the company, so I can summarize for you. So what MCP is right now? MCP is to 2025 is what REST is the API. REST was in 2005. So when the web app system developed in 2005, that time REST API is the game changer in the world. Every system, every API is nothing but the REST API. So REST API changed the whole world. The same way MCP has is changing the world right now. Every agent has multiple hands, multiple tools, and those tools are now MCP tools. Just like a USB mode. Just like a USB mode. So MCP is just like a USB charger, USB-C mode thing. If data fetching, data taking, calendar sending, email sending, whatever, or going to CRM, fetching data from CRM, everything is now MCP tool. Okay. So now we are trying to see not as a variety of APIs and all. Now we see things as a only MCP. We don't we don't now consider databases and API and all. We have only one thing called now MCP tool. The MCP tool has become the single system of getting the power of accessing the databases, performing a task. MCP is single, I can say, method of giving the arm power to the agent. Agent can have power to write to the CRM, read from CRM, send email, send calendar. So this is called MCP. Okay. The companies that standardize the tool interfaces early will have 1 year to 2 years month advantage. So generally, many companies try to make MVP and they fail to deploy or productionize because they have never really understood the game of governance, and that's why they fear that if anything goes wrong, then how they can take care, how they will take care of those fallouts. So they have no idea how to manage the standardized system, how to manage the best possible compliance system, so that things will not happen in wrong way. And even it happens, at least you have a safe guard for you that you have followed the best practices, and this is the best you can do. So better to be aligned with the compliance system so that you will have a double advantage: money saving, time saving, and the more brand value in the market. Okay, the next point here is that governance is not a tax. It is a prerequisite for the autonomous agent. So you can't deploy any autonomous system, agentic system without governance. Without governance, your autonomous agent is actually a human supervised agent with the extra steps. So without governance, basically you are always at double triple risk basically, and you always need to have humans to check what is going wrong here. The maturity model. So level one, like ad hoc agent, takes 4 to 6 weeks to deploy, and level three, governed plus evaluated agents can take 2 3 days extra only. So, so we hardly spend much time. We take very small time to apply that, but advantage is too much. So standardizations compresses the time to value. So you spend quite less time, but you have very high return on investment in that way. So every agent should have a kill switch, not just for the safety, but for the cost. The ability to pause an agent that is spiraling saves an average $8,000 per incident in our. When the incident, you have a high chance of losing big money. Example, if you are giving the loan system, or you are trying to deal with, you are creating a deal system. So whatever your company offers, financial services, loan services, insurance services, you have a very penalty generally very high in the every game. You can give wrong big loan to the wrong person, so you will lose $20,000 in one go directly. So your incident cost is very high generally, and that can be mitigated in a very big way by this autonomous governance compliance based agent. That is the message we want to. Okay, so one example in terms of timeline and all. So you can say foundations take 1 month mostly. MCP servers for 3 core tools is a typical job. When you apply the governance, basically, it means you apply the OPA policy, open policy agent policy, and approval workflow. It will reduce the risk and all. And next step that you can also evaluate now how it is performing. You can evaluate the real achievement, what they're doing, trajectory evolutions, and then see that compared to the past, how things are happening right now. How now there should be less incidents, there would be a more customer, better customer service and all. So you can analyze in our KPI also. So the first layer you do the foundations, then apply the governance, compliance and all, then evaluate the performance of your agent as a whole. You must feel that you are having better KPIs now and less risk now, so you can have all these metrics. So this is a typical trajectory of making production ready agentic AI system. Okay. So MCP is open, supported by the Anthropic, Llama Index and all. Uh, so I will talk about this Langsmith versus Phoenix Plus versus the, it's all a company basically. I'll explain to you in the next slide now. So let me show you the next slide. So this is a typical scenario of prototype illusion. You make some agentic AI, you have MVP basically in the company, but you feel that you can deploy, but you don't deploy because of lot of risk. This is a typical game of MVP. In the real world, when you try to deploy it, you will get attacked by the clients. There can be a lot of issue with the client. You pay a lot of wrong payment to the wrong person and all. You find out there's so many penalty from so many aspects that you don't really difficult to take courage to deploy it. This is a real scenario. Because one more reason, LM is not so deterministic. LM is probabilistic basically. So even you don't know what LM going to do next time now for the same scenario. So LLM also is not deterministic. There's also one challenge right now. So agentic AI is powered by LLM, and that's why we get a lot of challenges basically. So this is a real scenario when you try to deploy the AI agent. Okay. Non-deterministic chaos, silent regressions, latency. So latency also go up in a big way. Latency spikes, and there is a lot of also hallucination right now. So in the key takeaway or in a traditional software, unit tests are binary. In the probabilistic LLM power system, okay, the passing is a spectrum. We don't know what LLM is saying is fully true or not. You never know because LLM is only probabilistic. So one example of MLOps versus the LLM ops and all. So in MLOps, we used to have a typical classification regression. We have a table of data that time. Now in the LLM ops, we focus on the document database. That is an unstructured basically, multimodal, image, audio, text. So now in this new world of multimodal system like image, text, PDF and all, that's why it's more complex. Okay. We are going through a very tough time right now because challenge is humongous. Now, models earlier we used to have very less model. We have XGBoost, we have random forest model for classification and all. Now we have so many patent model, GPT-4, GPT-3, this, that, even fine-tuned model of the Llama 3, Llama 4 and all, and then LLM plus RAG also. So we have multiple now options right now. So it's difficult to really focus on one. There are so many possibility and all. Number three, the inference economics. So generally, it's very costly in the LLM agentic system. They charge money per million token. Example, they charge $5 per million token and all. So whatever they are doing, they are burning the money, right? Because they are using the tokens. Okay. So it's a very sometimes you find that the cost is very high customer call service and all, they use so many token right now. Suppose they consume, suppose 200 million token. The 200 into the $5, So generally, when you try to have a lot of documents, fetching documents and talk and all, you spend more and more tokens. Then it's more costly for you. So there's so much challenge right now in the LLM ops right now, because unstructured, multi-modal, image, text and all. So many variety of LLMs plus LLM RAG and all. Then token-based economics right now. And last and but not the least is the chance of hallucinations, toxicity, biases, PII, it means private information data, leakage. So these challenges are humongous. That's why 99% of the agentic AI is not deployed in market right now. These are the main challenges right now. Okay, for deployment part. Okay. If any doubt, raise your hand. Ask any question. Okay. So I think it's quite. If you any doubt, please message on the chat. I will try to answer it. So because of these challenges, the production is not happening in this agentic AI system. So selecting the foundation basically. So enterprise, so you can write down know that in any system there is chance of high hallucinations risk and all. So what to do it? Training data set, LLM basically, LLM APIs, enterprise apps. You use a prompt for that. So it's a typical very basic embedded LLM apps. Okay. Use some GPT-4 and use some database, and that's called typical embedded LLM apps. Then we have fine-tuned SLMs. You fine-tune the model with your domain data and all, and then it becomes fine-tuned for your domain or for a company. So it's a very costly game because you have to train the model. You have now privacy is better now because now you have LLM at your promise and all. So privacy is high right now. They high up, but the cost is very high because you have to train the model with your database right now. Oh, sorry. So it has some advantage that it maintain the privacy at a higher level. It also, but it has a higher cost to do so. Okay, and you will always keep training the model every 6 months, every 3 months, every 1 year, because of your database, your information, your company data is also being changed and modified. Okay, and then RAG, that we use the some PDF database plus LLM model. So here we have a document of your company and your one LLM basically. Both are used to develop the RAG basically. These four are the typical LLM architecture in the market right now. So since all is based on the so this is all based on the vector DB. So every documents become vector right now in 3D and all. So it's all about semantic search. So I'm telling you the nitty gritty of the LLM app basically. Everything is nothing but a vectorized system. You try to vectorize the paragraphs, sentences, whatever, and you see this kind of system. So this is the new kind of world coming up. This it empowers semantic search. Okay. So in the LLM CI/CD pipeline, what happens right now? You have prompt registry. You have a prompt. Prompt can be different. Then you have different output right now. For the same LLM, basically, you may have a different prompt, different output and all. So you manage the version of prompt. Okay. Okay. Then we have a integrations test suite. So we have it includes the baseline, edge cases, and the adversarial inputs and all. So we create a lot of scenario of bad scenario, like what happens when someone put prompts of this type and all. So we create multiple kind of prompts to see the adversarial scenarios, the edge scenario, the prompt injection scenario also, So we try to figure out the possibility of the edge cases more or less. Then we have code-based checks run for JSON and all, followed by the LMS judge semantic evolution. So evolution engine, then simulation and all. We simulate now multiple turn chat, multiple kind of chat navigations, testing for the agentic workflow and all. And the last, we see the Bifrost gateway like basic production game, na 1% traffic rollout with the real time observability and the automatic. So it's all about the green and red, na canary game, right? So this is typical CI/CD pipeline for the LLM system. So any LLM systems, this is typical CI/CD continuous integration, continuous deployment pipeline basically. So prompt registry to the golden data sets to the evaluations engines to the simulations and to the Bifrost gateway like canary system and all. This is typical CI/CD for the any LLM apps. Okay, so I talk about the reliability aspect that is very commonly discussed in the market. So there are three main part, like how much they are consistent with the question asked. Does the agent produce the same outcome when run multiple times on the identical inputs? Second thing, robustness. Does the agent survive semantically equivalent but syntactically varied instruction? Example, you can rephrase the questions whether they are giving same answer or not. Then fault tolerance, does the agent recover from the transient infrastructure failure? Okay, these three are the mostly discussed in the reliability game and all. Okay, so I think React, I think you may know about the strategy of the prompting, React reasoning and acting, reflection. So it is a typical prompt strategy. I think you know that all the agentic system mostly either use the React or reflection. So you apply one of the strategy basically generally, React by default. Okay. So typical prompt strategy that governs the your agentic AI system. So an agent, you have a logic or strategy either in a react mode or the reflection mode. Okay. Uh, so example, rate limiting the causes the highest reliability degradation, exposing the weak backup logic. I think we can talk about very differently all this. There is challenge. There is a attack on your LM app. So how to reduce the attacks? So there can be a attack from someone. So there are multiple things in the system. I think it's very 1 hour 2 hour is quite less to discuss because there's so many surface area where you can be attacked. So there is attack from the any cyber guy who try to attack the APIs and all. So there are multiple aspects, typical cybersecurity aspects, typical LLM based aspects, typical CI/CD aspect. From various aspects, the system can go down. Okay, that's why we have to follow the best possible governance rules because governance rules are made while keeping all those possibilities and try to become proactive. That way. So a book flight New York to the lax. I need to fly from. So this is a two different questions. We they are semantically same question but they are differently written. So we expect you must get the same answer. So we expect that ki what you customer can ask question in this way or that way, but if the intention is same, then LM is supposed to give the same answer. So this is called action metamorphic relations. Okay, the correctness is the defined by end state equivalence. So that is this is the typical we really expect from the LLM. If it's not happening, we have to really check that. Okay. So traditional NLP evaluates output text similarity, which fails for agent. So for agent also, we have same kind of hope. Even someone asks to do some task of flight booking and all, you can ask the question of flight booking in different manner. You can rephrase the question, but agent must perform the same set of tasks. Got now? So customer can say that I want to have the data from my CRM regarding this new work, or he can say the same question in a different manner altogether. But no matter whatever is said, if the intention is same, then the agent must perform same set of tasks in that same sequence. That is game and all. Okay. And the last aspect is the size. We want to reduce the quantum bytes of the model so that it can be light. We can deploy on multiple ports, multiple Kubernetes and all. So even we tomorrow scale up, we try to now create the system for 1 lakh person per minute. We can really handle that. So we need to have a light model which can be easily deployed, and we can have a also system of Kubernetes and all, which can really have multiple ports to manage that. This one game is that try to have a quantized low size model which can work without losing much accuracy. They must be small size. Okay. So this is a typical aspect of the LLM. Basically, we want to have a low size model without compromising accuracy. Then we have a extra pruning. Then we can also fine tune the model so that it can be a low size. So there are multiple. I mean, LLM is all about a set of the new world. We have so many aspects. So you have to also take care of this also, because when you try to deploy one agentic AI system, so LLM should be light enough. It should be quite big. Otherwise, will be a large hold period. There would be a latency issue. People can get response after 5 seconds or 8 seconds. They will be pissed off with this late response and all. So also we have to take care of this after the latency also. So latency, the cost, and the accuracy, all three matters. Latency, time, the customer wants fast answers, fast actions. So latency, the cost, it should be optimized cost. And third, the all the accuracy and all. So what we tend to do, it must do in that way. All three have to be done. Okay, without hurting the any system, without hurting the private in privacy information, without hurting the other things also. So this is a summary of our approach today. I will not go now. We will just wind up in couple of minutes. So we can just open the floor now for the questions also. This one example here, when you have cloud GPU, we have edge devices, and we have multiple, we have Kubernetes clusters and all. And so that we can scale up, we can really serve the same LLM app, agentic AI systems for 10,000 persons per minute. So when you try to deploy and when you want to have a large customer base using your agentic AI system, it has to be done through the Kubernetes and all, so that it can be easily, managed. So things are coming up in a big way. There is Kubernetes orchestration and also horizontal auto scaling and the dynamic GPU scheduling and all, and the Kubernetes and all. So this is a hybrid edge cloud routing and all. So example, something can be done on the edge devices, like inference can done on the edge devices, and some can go to the cloud. Example, robot also, robotic robot or any kind of plant or any kind of system. So something we want to have a latency issue, so we cannot really wait for the cloud based system. So that edge that GP, that particular Raspberry Pi, Arduino, those things must have the that simple CPU to infer the basic thing, where latency is the critical, is the critical. And then manage the cloud service for non-critical things, where latency is not a challenge right now. So we have to have a strategy of using the edge device based inference as well as the cloud based inference. Okay. So right now the game is very complex right now. We have to take care of multiple aspects. I think we have covered so many angle right now, but I feel still we can have some more angles left also, But these are mostly covered maximum number of the challenge in the LLM systems. Okay, so the guardrails take care of the reliability issue and all. Okay, they can be also reproducible. Okay, you can figure out that whatever you do, you ask same question again, they will do the same thing. It won't behave like a probabilistic game. It look like a deterministic game. So we want to have a agentic AI systems reliable, reproducible, explainable, okay, and secure and private basically. It respect the PIIs and all. That is the game. Okay, so this is a typical game. We have a testing and the CI/CD do. This is one company called Prompt Fu. So there are many tools. I can explain. There are many tools right now. I'll give you a list of tool set. The main tool set now for multiple things. I'll say you tools list right now. Okay, let me show you tools now. Okay. So example, MCP server. So for MCP server, we have GitHub MCP servers, we have Slack servers, we have Chrome Dev tools, we have Puppet Tree tier, we have Amplify, we have AWS Bedrock, and also this all are the MCP servers, and everything has a lot of pros and cons. Example, GitHub has they manage the repos, create the PRs, fetch the file content, and automate the CI/CD. Slack MCP, they manage post messages, read channels, manage and all. And this Chrome basically have web scraping from the websites, screenshot capture pen. So you will get lot of tools on this server regarding the web scraping and the screenshot and all. So based on your task of agent, we decide you want to go for which MCP servers, or maybe you need to have multiple servers as well. So Slack, Chrome is good at the web scraping and the screenshot capturing and all. Okay, so you can see Notion is better at the query database and the create page and all. So there are many tools, and you can use one of the servers to manage your agentic AI system. Now, typical how to evaluate the agent basically. The MCP evaluate is the one framework, core, agent as the judge, agent change bench, outer Libra and all. These all are the framework of agent evolution. So this is MCP based automatic evolutions, multi-domain task generations, automated verifications, and seamless agent and all. So you can see here, this is core, agent, change bench and all. You can see here, this all are the framework, and each framework has some key metrics also. Okay, if you get time, you just go through one by one. LLM and the agent evolutions platform. So you know that your Raga is famous, right? Raga is for RAG evolution. So how RAG output is coming, good quality, bad quality and all. You can use Ragas for the RAG evolutions, prompt for the prompt injection, prompt testing and all. Even someone put the wrong prompt or bad prompt, they will figure out this prompt has a bad intention. They will not take the question, by the way. So there are multiple things. So for hallucination, basically you can talk about Galileo, then Fiddler for the model monitoring, Maxim for the governance focus. So there are multiple agent LLM evolutions platform right now. You can choose one of them based on your focus area. Okay. Now same with the agent benchmarking metrics. So we have goal completion rate, we have autonomy index, we have multi-step resilience, we have business impact efficiency and all. These are all other metric framework basically, and they have a goal. Example, this first one goal completion rate will did the agent achieve the state goal? Okay, they will measure it. This will measure how much human interventions was required. Example, your agent is performing one loan approval task. So they will figure out how many times human interaction were required. Maybe out of eight step, you require only two times. Example, multi-step resilience. So when you have can the agent recover from mid task failure? Example, if there's some failure in some task, whether the agent can recover or not. So these are all the aspects to judge your agents. So once you deploy the system, you can figure out how good the agentic AI system is, by just judging in this manner, resilience manner, human intervention required, not required at all, you know, did agent achieve the goal or not, So ROI per successful task. So these are all measurement criteria. Okay, that is them. Then we have a this observability and tracing system and tools. This famous one, Dynatrace is most famous tool right now. It's all about real-time agent tracing, live topology maps, intelligent alerting and all. Then we have the Datadog LM observability. Then we have a CloudWatch on the only AWS. They all try to see that like how your agent is performing. Okay. So you can really monitor the agent health, how many agents are active, not active, how many tools fail or not fail and all. So you can really trace your failure of the tools and in the overall agent as well, right? These are the typical tool to monitor and observe your KPIs of the agents. Okay. And I give one simple guideline how to do that. Start with a simple MCP. Choose fast MCP or any Chroma MCP, whatever and all. Then pick one orchestrator like LangGraph for deterministic control, Blue AI for the role-based teams, AutoGen for the conversational agents. Then add the one layer of governance called OPA, Open Policy Agent. This will try to make more sophisticated system for fine-grained policy. And if you have a Kubernetes system, use the Kyverno, not the OPA. Kyverno is good for the Kubernetes-based system. Okay. Then next step is the choose an evolutions approach, like deep evolutions for the unit test. Okay. Smith for the chain users. So these are the used for evolutions approach. Then Aries Phoenix for the open source trajectory analysis. Then the last part is deploy the observability. Now Aries Phoenix or Dynatrace and all used for the observability and all. These are the steps you can do if you want to productionize your agentic AI system. Okay. So this is what we wanted to convey. If you have any questions, please ask it or put in the chat. Yeah. Any question, to just let me know. We have covered so many things in a very short time. I hope that it is not too much to grasp. Okay. Any questions for me? I'll just summarize in just 2-3 minutes. If you have any question, please raise your hand and ask question. Okay. So we have talked about the cost aspect. The cost is shaped by the governance that we have discussed right now. We have done some kind of calculations for the customer care and retail analysis agent and all. Okay. And then we have seen the risk and compliance issue. Okay. We have seen the cost saving also and the method to manage that. So we have seen how we manage the mitigate the risk. I know this is strategy of mitigations. And okay, so we use a least privilege and OPA policy and all. This is a strategy to minimize the risk of the agentic AI deployment. Then we talk about the technical depth. So we talk about like how we implement it. We implement tool call logs by in this format and this manner. We apply policy and all. Like this is how to apply. That is main thing. How to apply that. You use the Rego code and like this code we apply it to enforce the policy. Okay, this way we have done it. Okay, and then we talk about like what MCP is. Okay, MCP is the like God right now for this world because what REST API was there 20 years back, now this is MCP. Everything is MCP. Every tool, every work, database access to the any kind of API or any calendar sending, email sending, whatever, everything is MCP right now. Okay. Governance is really adding the value because it saves the cost, especially when there is an incident. It really saves the money because you expect some kind of incident every month. So you can pay out 20K, 30K, in one incident. So you will save that money in a way. That is the governance benefit. Plus, you will have better reputation of company and the world that your output is more compliant. Okay, talk about the maturity level and all, and then we're given this idea how to do that. First, we focus on the foundations, then go to governance issue, then go on the issue of evolution. These three are the step one we take it. 1 month, second month, third month. This is the strategy we should apply that to roadmap for deploying completely. Okay, and then talk about this real scenario, the basic MVP game and real production game is very complex, very vulnerable. Okay, then we compare why LLM ops is very complex compared to ML ops because the LLM challenges of hallucination and all, and multiple challenge as well, multi-model and all. Okay, then we talk about the core scenario of the LLM basically. Then we talk about the basic thing how LLM and all system is vector based, so it is more kind of semantic sense and all. Okay, Then talk about the CI/CD pipeline of LLM system. So these are five steps of the CI/CD game. Then these three are the three angle of the reliability of the game, how the work is persistent, robustness, and the fault tolerance. So even you ask question in different manner, they can do the same task. So this is the case, and there are two strategy mostly of any agent, react or reflection and all. And that's all we have covered. Kubernetes is something advanced. If you want to scale up in a big way, use the Kubernetes and all. Then this is the four angle of the guardrails: reliability, reproducibility, explainability, and the security and privacy. These four are the main aspect of the guardrails, AI guardrails. Yeah. So this is finally we are then talking about multiple option MCP server seats list. This is the general agent evolution system. This is the many option right now with you. Then we have LLM agent evolutions platform. Okay. Okay. And then we have agent benchmarking and all, and then all. So yeah, any question right now?
Yeah, Naveen, I have pasted my question in chat.
Yeah, please. So what is the question?
So
Can you repeat?
yeah, yes, yes. So it is like the first slide itself when you're talking about the governance. So I just have the question to opt that to apply the governance policy and all. We need to pay, right? We have to. It will be cost for us.
Yes, yes.
So is this cost manageable or high, or like how frequently the government is charging for us? Suppose if I'm going to create some agent.
Yeah.
So like how I'm seeing it, if I will be doing some prompt with any of the AI agent, so it's giving sometime it's redirecting to another topic, like which is
Yeah,
unnecessary. So is
yeah,
that
true.
meaning that it's not the governance one?
Yeah, I think governance is not costly game. It's all about being aware
Mm-hmm.
and being aware of all the steps and applying it. If you remember, I have gone through there are slide we're talking about step. So you use OPA system, open policy agent system and all. So you can learn OPA rule, okay, and then see. So there is a right now in the market there is standards. There is a already compliance rule in the market, and you can get OPA in the market very easily. You go and just apply OPA in your layer. After making a foundational agentic system, add one governance rule. Every action may be followed by one extra layer of OPA layer. For example, when you have multiple tasks in the agentic systems, every task needs to have one extra layer of OPA layer. So OPA layer will verify whether it is right or wrong, whether it should go ahead or not. So we apply extra layer so that all the actions are verified and are less risky. So you can just explore the OPA and just go through the some blogs and the articles there, and also GitHub. Already there in the market. People right now don't spend much time. That's why they feel that it's not costly also, it's not much costly. It's all about being aware and being aligned. It is not costly game. It's just like spending some time, maybe 1 2 weeks and all, and figure out all this OPA rule and apply that. Okay.
Okay. So I just want here maybe you can guide me like if create I'm giving some because I'm working as a developer. So if I'm asking some of the prompt to Copilot to read to review the PR or something, but again it's giving unnecessary the things which is not required to review. So you
Yeah.
said if it is governance, it's come by the OPA policy.
Yeah.
It will ignore these things.
Yes, yes. It will minimize that. It will, yes, it will minimize
So
that part.
how
You're
can
right.
I apply? How can I like I can go and apply for this OPA policy?
You just
Uh,
Google it, OP policy,
okay,
just Google it on the GitHub and all, you'll get already there. So OPA is must in right now. That you can just Google it. I can spend, it will take at least couple of hours again, talk
hmm,
about OPA and all, because OPA is already well defined. There is well defined policy in the market. in general, and people have built in a collaborative manner. So many company, many team have worked over many years to develop that policy system and all. So you can just Google it. Already all the cloud also right now using the same thing, more or less. So it is open source completely.
Oh, so okay. Yeah, I'll Google it.
Yeah.
Yeah. Thank you.
Yeah. Thank you so much. Any other questions? So
So,
let's say, yeah, please.
yeah,
And
Naveen, like, hey, Vaishnavi this side. So, quick question. Thanks for the insightful session. It was really good. So, the challenge that I face, right, anytime I go to the client for any proposal pitching or something, they're really scared about their data, right, on the GDPR compliance, etc., etc. So, how do we tackle this? Do you have a real-time example, or how do you convince? Can you give me an example around it?
So PII, so we have already on the cloud, they are already developing, they're having right now. So PIIs, toxicity, biases. So there's complete set of the rules. And you work in Europe or you must have GDPR and also
Yeah. Yes.
then you need to apply. Europe is very tight about GDPR. You can't develop. So regarding data as well as the AI system, both they you have to apply. You have to apply the GDPR rules. So GDPR already you can explore the GitHubs. We have already made some kind of codes, Python codes there, which try to check that. So example, GDPR talk about privacy, talk about the bias and all. So there is a Python code people are building together. Uh, Example, we have guardrails, AI guardrails and all. So already
Right.
community is there. They are developing together, and you can try to use that community service free of cost.
Okay.
And it's all about spending time, okay, and reading the GDPR rule first of all, and then trying to find the Python code which try to take care of that aspect.
Got it, Naveen. Thank you.
Yeah. Just check the AI guardrails and check the GDPR based guardrails and all. You'll get a lot of GitHub files and just explore that. Thank you for nice question, by the way. Any other question? Yeah, let's stay in touch. Let's stay in touch. I think because it's a very big area, AI governance, all this very big area. I mean, safety and AI safety and those kind of CI/CD, LLM ops, very big area. I mean, changing every week. They're changing in a way. So let's stay connected. We can discuss anyway. If you want to deploy somewhere, if connect to me in case connect to the team also, and we can try to help you deploy and manage the system. Okay. Thank you so much. Thank you for listening
Again,
very
how to stay
patiently.
connected?
LinkedIn, you can connect to me on LinkedIn also. That is one way. So I'm there on the LinkedIn.
Okay. And another question, I missed first 1 or 2 slides, joined late. Is it possible to get access to the recording?
Uh, Maybe Manish can give answer. Manish, are you there?
this session is already being recorded. It will be uploaded to our company's YouTube page. You can search Greater Insights on YouTube. You will get to our page. And you want to be connected with Naveen. Naveen, if you can show your LinkedIn page while you're sharing on the
Yeah.
screen,
You
so they
can,
can send you an
yeah.
invite right away.
Okay, okay. Just 1 second. 1 second. Okay, this is me. Second. Yeah, this is me. You can just connect to me. So, okay.
Yeah, thank you.
I can put my email ID in case you want to reach out. I think chat is not enabled. So maybe my email ID can be taken from the team also. You can type, yeah. Okay. Manish, can you share the email ID? You can say email ID also. So please approach me for deployment of any agentic AI system. So, okay. Thank you so much for hearing it patiently. I hope it add value to your knowledge for your system. So we can pause
Thanks,
here.
thanks a lot, Ravi.
Yeah. Thank you. We can stop here, then pause here. Take care. Thank you so much. Have a great evening. Yeah. Thank you, Santosh. Thank you so much.